Oh, there we are. Awesome. Yeah, you're going to start the timer? Awesome. So welcome to 30 minutes of private AI. I'm not going to talk about like the architecture side of stuff. I've been spending the last 6 years in the field of AI, working with a lot of customers in different kind of scenarios. And what I want to talk about is, who's familiar with NGC, Nvidia graphics GPU cloud, Hugging Face, stuff like that? Okay, so there's a lot of stuff nowadays that makes it really easy to run some form of AI in some form of platform. Could be your local laptop, could be something else, but we started playing around with AI for customers before that era, and that's kind of, I want to guide you through how we started 6 years ago, where we are now, what the dangers are still, and I'm going to show a live demo that, fingers crossed, will work. And I have one question to you all. So who read one of my books before or owns one? Okay. Think of a question about VDI. Just like, I'll when the demo starts, I'll ask you to ask that question, and we're gonna see what will happen. So my name is Johan from Amersfoort. I'm a technologist at ITQ. 50% focus on EUC, 50% focus on artificial intelligence. So what is AI? Who knows who this guy is? Cool. Alan Turing. So I made one mistake when first presenting this session, because I thought he was the guy that broke the Enigma code. If you watch the video, like the movie, The Imitation Game, it shows that he broke the code, but it was a team of Polish people that broke the code where he was a part of. And I presented that at the Polish VMUG. And it's still alive, yeah. So he also created a Turing test, which is a test that states if something at the other end of, let's say, a line, other end of a conversation, is capable of mimicking a human, it passes the test. And that's, I think, currently one of the most commonly things that he's known about, the Turing test. If you haven't seen The Imitation Game, by the way, it's an awesome movie, so I highly recommend checking it out. So there's two types of AI. The first being general AI, which, you know, if you look at movies like Terminator with Skynet, or in this case, any of the Marvel movies where Tony Stark uses Jarvis to pull stuff off, is really awesome, but we're not there yet, and I don't have an idea or assumption whatsoever if we're ever gonna be there. Because, well, you know, AI might take over the world, but this actually happens a lot. And I'm gonna in a bit show why. So there's the other way, the other type of AI, which is narrow AI. Who knows who that guy is? Okay, it's Jin Yang from the series Silicon Valley on HBO. Again, really, really highly recommend checking it out. He made an app that's capable of detecting if an object is a hot dog or not a hot dog. But a more commonly form of narrow AI is a technology or a solution called AlphaGo. This was created to beat the world's best Go player, and Go can be seen as the world's most complex board game. It's again a documentary on, I think on Netflix or HBO, where you can watch how they built this, what steps they needed to take, what mistakes they made, and how eventually they might have beaten that player. So it's a great documentary. Now, AI has a couple of subsets. The first being machine learning. And to explain what machine learning does or how it works, I want to talk about an example. So, you know, the first Nigerian prince might have sent out like proper emails, like, here's money, please take it from me. And what you can imagine, like this happening 20 years ago, and you were a programmer, you didn't know about machine learning yet, you might be like, let's code something that might block that email, right? So if, in this case, the sender is a Nigerian prince, and the host is that, then block the message. Now, that works for a while, then suddenly a different Nigerian prince sends an email that needs to be blocked as well, and the only thing you know is an if-then-else loop, and then suddenly, like, you have a shit ton of conditions, and that's not gonna work. Now, then someone found out, like, what's really interesting is, like, let's use something called machine learning. So machine learning works with structured data. If you take an email, it's completely composed out of structured information, things like a topic, a subject, a sender, a receiver. The body is always the same. And based on those structured pieces of information, you can train something to detect, well, to determine if an email is good or not. So what we have been doing is training spam filters to determine if an email is spam or not. So, like, in the early 2000s, you always had, like, in the first email clients, the spam button. What we were doing is not just marking something as spam and put it automatically in our spam boxes, but we were training algorithms, models, at companies like Hotmail or Microsoft to improve their spam filter, their algorithms, their models. So, yeah. And another subset of machine learning is deep learning. And to explain what that is, I'm going to show an example. So it always works based on a neural network, and a neural network can be basically compared to the neural network in your head, your brain. What you basically do is you have an input, which is something that looks like a cat, and the neural network predicts, in this case, it's 96% cat. Now, what you then do is you basically train the network. So you have a data set with cats, dogs, and Ewoks. You feed that, or you mark that, so you label the data. You feed that data into the neural network, and the neural network is being built. So it creates all sorts of links between the neurons. And at the end, what the neural network will do is create a prediction. In this case, a percentage of dog, cat, or Ewok. To test and validate the neural network you just trained, you feed in a new picture of something. And then the neural network will determine, in this case, it's 45% dog, 3% cat, and 52% Ewok. Any questions so far? Okay. Now, oh, that's twice. Let's talk a little bit about AI in the enterprise, because now you have like an idea of what AI is. Who has seen this slide before? Okay. This is the last architecture slide you'll see today. I think it's really awesome, and I'll explain in a bit why it is awesome. So, who has ever tried to build a do-it-yourself AI platform? How was that experience? Okay, I'll call it something different, but yeah, I agree. So, what I'm going to explain now is the process we went through 6-7 years ago with a customer. So the customer had a specific question. They had multiple data science teams, and they worked on specific types of data for oncology research. Back then, there wasn't something like an NGC or Hugging Face or public available models or whatsoever. So they did everything themselves. So this is the process I went through to build a virtual machine that was capable of doing a couple of things. First of all, run Jupyter Notebook to be able to interact with a container. Train, so there was a training workflow based on inside that container. And the last piece was a little bit of inference, so to use the data to detect if something is, well, in their case, if a cancer cell could be detected, yes or no. So this is the process. We took a VM, we installed Ubuntu, we chose a specific version, we updated the packages using the update command. Then we found out that in order to install drivers, you need to do something different because you need to install make and GCC. Next, we installed Nvidia drivers followed by Python, followed by TensorFlow, CUDNN, so that's the deep neural network framework that's tied to a specific CUDA version, and CUDA is the API that you could use to talk to GPUs from a calculation perspective. Then we tested a script of a customer to validate if everything was working right. It didn't, because we needed to install TensorFlow with a GPU capability. So that's a different framework, that's a different package. Then we tested the script again, which worked, tested the app that the customer wanted to run, that failed. Then we installed a specific version, which was TensorFlow 1.14, followed by TensorFlow GPU 1.14, tested the app, this didn't work, because we needed a specific CUDA version, which was 8. Then we tested the app, which didn't work, because we needed a specific CUDNN version as well. So we installed the package, tested the app, didn't work, adjusted pass, because, well, if you have multiple CUDNN versions, multiple CUDA versions running on the same machine, you need to adjust those paths for an application. Tested the app, didn't work, because 1807 or 1804 was not supported from the app perspective. And this is what happens after literally 3 weeks of all of this. So we spent 3 weeks getting the whole supportability done, compatibility done, and this is just like one big shitstorm. So nowadays it's a lot simpler. Who remembered this guy? Right, so this is really interesting. This is Mike Levy. He presented amazing discoveries, and apparently he's a US guy, but the only country in the world watching Mike Levy was the Netherlands. So I presented the same slide in the US, no one. There's one episode of Friends where Joey is in a commercial with him, the one with the milk cart. You know it, right? Yeah, so that's Mike Levy. So he had one quote, there has to be a better way. Well, there is. So using that better way, you take a VM, install Ubuntu, install the right version, update the packages, install make in GCC, Nvidia drivers, Docker, pull a TF container, so a TensorFlow container, and you're good. Now, this is NGC. So when we started with the project, NGC wasn't there yet. We worked with Nvidia in the very early stages in kind of a beta situation or alpha situation to get this done. And we worked together with them to basically create a couple of containers with the specific frameworks that we needed, like TensorFlow with a specific version. And what they do is build a full container image, a Docker image, with the right version of CUDA, with the right version of drivers, with the right version of TensorFlow, TensorRT, CUDNN. Everything is tied together in a single container. The only thing you have to do is pull it, and everything is there. This is also a little bit how Hugging Face works. So you basically pull a container if you choose to go the Docker route, and then everything inside that container is already tested. It's already validated. So it's fairly simple to run such a workflow. ngc.nvidia.com. This is fully free. The only thing you have to do is register for a developer account, and then you can just start pulling stuff. That's what we're going to do in the very first demo. So this is a pre-recorded one. Are we on time? Good. So what we're going to do is start Python and open up or try to import TensorFlow as a framework. And it's unable to find that right now. So what we'll do next is to go to a browser. And this is the NGC platform, so what you can do basically is just browse for some kind of framework that you need. In this case, TensorFlow. I'll click it, and what's really cool is if you go to the, you see the pull command is already over there, so you can just copy it and paste it. There's for back then for TensorFlow, there was a TensorFlow 1 and a TensorFlow 2 branch. So you need to check the right version. But if you go into the details of that individual TensorFlow Docker image, you can see every single framework that's in there with every single version, which is really helpful. You pull it. This was intentionally fast-forwarded, simply because in this case, the TensorFlow container is around 8 gigs. And honestly, that's nothing. So I played around with, and I'll show that in the demo, with a Hugging Face application in the last couple of weeks. And pulling the application by itself at first took, I think it was 8 gigs. But then pulling in all sorts of models and other frameworks and dependencies it has, I ended up with like 25 gigs in a single container. You can see now that it has been pulled. We opened it up, and it's fairly simple now to just open up Python, import TensorFlow, and you're there. So this, outside of like pulling, took probably 2 or 3 minutes, but you can see in a matter of a couple of minutes, you're already there. So I think this is really, really cool. Hugging Face. So who had played around with Hugging Face before? Cool, couple of hands. Basically just your open application. Well, it's basically Git for data science, right? You can find all sorts of open sourced applications. You can see within every application if they require a GPU or if it runs on CPU. That's one of the most commonly, or misconceptions I would say, that you need a GPU for data science related applications. Joe and you guys said it in the session before as well. That's not true. Most applications can just run on a CPU. Right, so what I did, I wanted to train a large language model based on biased information. So the books I wrote are about designing VDI platforms for customers, but I am quite biased on things like roaming profiles or stretch clusters or something else. So I fed that information into the large language model, and if I'm gonna end the slides, you should be able to see the application. Yes. So now we have a chatbot. This is I'll share the link to the application on my X account later today. It's fairly simple. You pull it, you load PDFs into the large language model. It starts adding the information to the large language model, and within a couple of minutes, you're able to ask questions about your documentation. So, who is Sean Bass? Oh, there's a typo there. Who does not know who Sean Bass is? Oh, one hand. He used to be the CTO for VMwareUC. So, and obviously, it's not updated, so he thinks still that he's the CTO of on EUC. And he is famous for one quote: "After nuclear war, only three things will still exist: cockroaches, Twinkies, and Windows apps. Denying that is simply foolish." If I would ask the same thing to ChatGPT, he wouldn't know that. So this is specific the information that I fed it into it. Any stuff I would. Is there any question you want me to ask? Yeah, definitely. How text to speech to text would be great right now. How many connection servers do I need for 10,000 sessions? Wow. Cool. So my books are not lying. So for a future project, we're going to feed, and this is off the shelf, right? So I pulled this 10 minutes. Oh, okay, good. I pulled this just from Hugging Face, but let me go back to the slides because I want to explain something. Yeah. This won't, because this does stuff based on biased data, not on. No, definitely not. So there's my mouse again. Okay, so question to the audience is: this was a public AI service, so should you use public AI services? And during the panel discussion, which was great, we covered a little bit of those topics as well. So should you? And I think this is one of the reasons why you should definitely think about before doing that. Like, and I think we talked about this already a lot. Like, who owns the data that you feed into a public AI service? That's a really good question. And just like think before you act is really important there. A second one is how biased or how like this is an actual screenshot. This is not like so. If you get convinced ChatGPT that 2.2 plus 2 is 5, the question is how well you should trust such a public AI service. And then there was this. So the 18th of November, they fired the CEO. The 20th of November, he started working at Microsoft. And the 22nd of November, he went back to OpenAI again. So the question is, should you focus or should you depend your entire future of your company to, in this case, a single person? Yeah, that's another thing to debate. Now let's talk about the reason, and this is, again, the slide. So why should you consider building it using a framework like this? Is to avoid those reasons I just mentioned. Like, putting it in-house keeps you, ensures you nothing, but it minimizes the risks of losing control over your data, over your applications, over performance, over availability, over everything. And in a project that I'm involved in right now, so I'm leading our AI proposition within our company. We're working with Nvidia to build a full chatbot based on Nemo, and Nemo is awesome. It does not come off the shelf. It's not that you're gonna pull a container and then stuff works. You need to actually do stuff. And I'm gonna quickly, since I still have 6 minutes, go through the next workflow a little bit. So. What you basically do, and I'm going to just go through the entire framework. This is how it will look like. So we have, in the deploy phase, we have different types of, we have an infrastructure with a fine-tuned model, with Triton running as an inference server. We use the Nemo framework based on an updated version of the NGC container, and what we're going to do is a couple of things. First of all, build a full CI/CD pipeline that lets us completely automatically update everything in the infrastructure based on new frameworks that have been available through NGC, but also secure it in such a way. We're going to use NSXT to fully secure it. I think even Carbon Black will be part of that. Let's see what happens there in the next couple of months. But what we're gonna do here is showcase how we can build a large language model with a chatbot. But eventually, has anyone seen the GTC keynote where Jensen, the CEO of Nvidia, there was a mini Jensen, right? We're gonna build a mini ITQ avatar, and the whole idea is on the user cons for 2024, where we are a sponsor, will bring the mini ITQ avatar on a huge screen, and using speech to text and text to speech, you can actually ask questions, because we believe that ITQ used to be a consultancy partner. Like, the only thing we did was consultancy, but consultancy is kind of, becoming old-fashioned. ChatGPT knows everything. So what if we put all of the information that we have, share it with the world using our own chatbot, and see if we can make the consultant of the future. So that's the goal. So before I end up, so who remembers Tay? Good, 2 hands. So Tay was a AI engine from Microsoft, injected in Twitter, or integrated in Twitter. So it was basically, it sort of passed the Turing test because it mimicked a real person on Twitter. And what happened with Tay is the following. So Tay, when she or he or whatever woke up, and look at the timeline. So the 23rd of March 2016 at 8:30 p.m. Tay was happy, right? So 9 hours later, Tay started to become a little bit grumpy. So 3 hours later, this is real, right? Now, within 24 hours, Tay became seriously a racist Nazi. So within 24 hours, Tay went from humans are cool to full Nazi. This happened. If you don't know the story, Google Microsoft Tay. This is one of the biggest shitstorm in AI in the last 10 years. Now, one part that I didn't mention in the previous slides around Nemo in our chatbot is one of the things that we're going to use is Nemo guardrails. So I think what's really awesome about building your chatbot, your large language model in your infrastructure is really cool, but you need guardrails to avoid it becoming a raging Nazi. So what you basically do with Nemo is you give it guardrails, you determine what toxicity it has, you can determine the bias, and make sure that questions you basically ask, for instance, if you want to train it on, in our case, consultancy or like VMware-related tech, and you would ask a question around Citrix, we would be able to either let it automatically avoid the topic, or like if I would ask questions around online gambling or something else, it'll just avoid the question. I think it's really, really important if you build something like this to keep those guardrails in mind. If you want to start with Nemo guardrails, this is it's a blog post on Medium. It is a great kickstart to have it run anywhere. Right, I have 1 minute and a couple of lessons learned. So I call it voodoo. Do it yourself AI. It's not just painful, it's voodoo. So stay away from it. If you still decide to do it, then be sure to literally write down everything you did. Like it can become very painful if you don't have a trace back. Create a shit ton of snapshots. Snapshots in this case are your best friend. Make sure that whatever you do, make it traceable. Make sure that you know what you're doing. From the public AI perspective, I think in this case, trust no one. It's make sure that you are aware of what you're doing when feeding private information into public model. And finally, this is my favorite one. Think before you act. It's with everything around AI. Like it sounds awesome. It is awesome. Like I think nearly all of the storylines I kind of write nowadays come from ChatGPT. and I use it just as a framework and create my own story around it. And final slide. Good timing, right? So if you have any questions, I'll still be here for the next couple hours. And also, like, I'm happy to I don't know, follow up or show the chatbot when it's ready. And thanks so much for attending this, and hope you have a great day.